Hello and welcome. This is Rohul Amin Khan, and I'm here to talk about the IPFS. What are the current issues with the internet today, and how IPFS can be used to address some of those. So, let's start. So, what are the real issues with the internet today? Well, centralization is the biggest issue. As we know, our data is concentrated with some giants. Like it's really scary that there's a few giants who have our data, and there are really few who serve it to us. So this opens up the door for censorship, right? It's strange that the way our data, it's strange that the way we are connected to the internet today is the way we get our internet today is more or less the same the way we get our water supply or electricity. If the main line gets cut, then boom, we are totally disconnected. If the government wants, then it can just cut the main line, and we are totally disconnected from the internet. Latency, yeah, of course, as the data travels from as the data has to travel from one point to another point, and we can't go faster than light, so there is a constraint. So there is latency, even though it's in milliseconds, but there is some, yeah, speed. This is what we want. Offline access. Offline access is the biggest issue with the internet. We can't access, the internet today isn't designed for offline access. It's quite strange that suppose we are here in this room and we are collaborating on a Google Doc sheet. It's not that we need to have the internet connection to be able to collaborate on this. And also, if we are communicating on some real time chat applications like Slack or WhatsApp or Skype, it shouldn't be like we should need to be connected to the rest of the world to be able to communicate with within us. If we are not connected to the rest of the world, we should be very much able to be collaborating within us and communicating within ourselves. So this is what we get. Something. This is what we get if you are not able to see the picture clearly. Location-based addressing. Location-based addressing, it actually is the reason for all the above issues. How we access our internet today is the website address or the URL we are accessing. It gets resolved into some IP address, and that is the physical address of a computer situated somewhere geographically. So imagine a situation when a lot of clients or a lot of computers are accessing the same information or the same URL at the real time. They're just hammering that particular computer. They're just training that. They're not only training that particular computer, but also the network it is in. For example, say when the IPL matches broadcasted live, then millions of users are accessing that same content at the real time from the same IP address. So it's just or a problem with the server. Just a problem for the server, and it creates situation like this. This is the physical traffic, and we have the traffic for the internet, which can be compared to this. Even though we don't have solution for this, we should have the solution for digital content. Oh, imagine a situation we are sitting like this in a room, and this was just to have you a visual effect for this graphical content. Suppose I'm sharing you a photo. I'm sharing you a URL of a photo that I have uploaded to Facebook. So this way, this gets uploaded to this uploader is me, and I have uploaded the photo to the server, and I've shared the link with you all. You all will be accessing that same photo from all the way from the server to you. So this is the huge loss of bandwidth. It's huge inefficiency. So things like this, if just imagine for the situation when Gangnam Style was viral, millions and billions of people were accessing the same video over and over again. So it's really a training on YouTube. So things like this came up after that. So how IPFS can address all these issues, and what exactly is IPFS? It's interplanetary file system. So what's there in this name? In the name, yeah, it's we are planning to have colonies on Mars, right? So if we'll have ever be able to have a colony on Mars, then what we will need before food is internet, I suppose. And if we'll have to go the same way, if we'll have to use the same infrastructure, the same protocol, and the same internet, then we'll, like, to do something, we'll have to literally, our data has to travel from Mars to Earth to request the server, and from Earth to Mars for the response. So what is the distance between Mars and Earth? It's actually it actually varies because they both like revolve around in an elliptical path. So the distance varies. That varies between 55 to 400 million kilometers, and 225 being the average. So the light takes around 4 to 22 minutes to travel from Mars to Earth, or vice versa. So it's 12 minutes is the average. So let's take the average for the time now. So if you are accessing some content from Earth in on Mars, then it will take around 25 minutes, 24 to 25 minutes for you to have this. So it's not gonna work. So how IPFS can help then? Yeah, content addressing instead of location addressing is the key. And content addressing is pretty much the way it sounds like. So it's like asking the network what you want instead of where you want. Like, it's not asking where is the content that you want. Instead, you are asking the network what is it that you want, and letting the network decide where it can get that information efficiently from. So distributing the content into small pieces in multiple nodes instead of having it in a centralized server. These two things are done by IPFS to, like, get rid of all the previous issues we have discussed. So this is the difference in the network structure or the data accessibility between HTTP and IPFS. So this, if we'll compare to the previous image we have shown with IPFS, then this should be something like this. So how can I trust everyone in the network? So you mean to say we need to trust everyone in the network? No, in a peer-to-peer system, we don't need to trust everyone in the network. We use cryptography to have them prove what they have done, they did right. And in a peer-to-peer system, we need to maintain the integrity of the file. For that, we need a way to verify that the file that we have shared with the clients, that they have downloaded and they have, and again we're accessing that same file from them, they haven't maliciously, they haven't done something malicious to this, or they haven't corrupted the file. For that, there is a great way that, like, every file has a signature. Yes, every file, every images, videos, or any content that can be converted into zeros and ones, or every digital content can be hashed into, like, there is a lot of ways to hashing content, but it's just that the hash of a content, hash of a digital file, it can be document, can be image, can be video, can be anything, it is the same. And again, if a small bit changes in that file, we'll get a completely different hash. So from the hash of a file, we can verify if we'll have the same image or same file, then how, then every time we'll hash it to the same hash format, it will give the same hash. But in IPFS, we do something like this. We take a file or take an image for this case, we split into different chunks. The IPFS splits big file into chunks. So you have split this file into smaller chunks, and each chunk has its own hash, and we are combining these hashes to get the root hash. So this root hash, we can then distribute these chunks into our network, and when we want this, if we want to share this file to someone else, we'll just share this root hash to them. So look, this is your root hash. Get the file wherever you want to get. So this will access the file from the network. It will gather the chunks and it will merge them together and will construct this root hash. This concept is called the Merkle tree, and these leaves are the actual file, and we hash them together to get some branches, and again we hash them again together to have ultimately to have a root hash. So this root hash, if we'll hold this root hash, we are holding the key to this file, the signature of this file. This will never gonna change. So this is the IPFS tag. This actually IPFS isn't about just about how we get the file from the network. It's the IPFS. It's a complete IPFS stack. IPFS is about moving the data in the network, defining the data, and ultimately using the data in the application. What we have discussed so far is about defining the data, or the Merkle tag we have discussed about. It's IPLD, and there is something else, IPNS. So how we name it, like we have DNS in our HTTP world, where we like convert the IP address into human readable name URLs, that when we access the URL, it gets resolved to IP address, and that this access the information from the same address. So human readability comes from this. This is IPNS. The URI, it's not URL, gets resolved into the key name, and it gets resolved into the content address. So yeah, with all this said, this is actually the graph of hash rate of Bitcoin so far. So with all this said, it just opens up the door for us to have things in a distributed network. When a lot of people with say mentality, with good power come together, then we get things like this. This shows the hash rate of Bitcoin. It's some 60,000. It's terahash per second. It's something 60 lakh 35,000. It's something 600 lakhs. It's it's about 60 million terahash per second. So it's enormous. It's just insane. It was even powerful than most of the world's supercomputer, even before its knee. So it's really great. When a lot of people come together to have the same purpose, then we get things like this. But sadly, all this is gonna waste. So it's not far away when we'll have something like this, but not for mining Bitcoin, but for storage in IPFS. People will contribute storage. We can even like we can even incentivize them for the storage they will come up with, so they can have some money. They can they can share their free storage, or they can have dedicated storage like this to earn money. So in the summary, I would like to say that IPFS makes it possible for the web to be built with small contributions of many, instead of the concentrated resources of some big giants. Thank you.